Hello everyone, welcome back to the DevOps interview series. If you're preparing for Docker DevOps and platform engineer interview, then this video is for you. Today's session, we are moving beyond Docker basics. We will be diving into advanced Docker concept and real-world troubleshooting scenarios that are frequently asked in the interviews. And most importantly, I will explain how experienced DevOps engineers approach this problem in real-time production environment. So let's get started. These are the topics that we are covering. We have Dockerfile, Alpine Images, multi-stage builds, image optimization, dockerignore, Docker volumes, Docker networking, Docker compose, production Docker files, troubleshooting scenarios, advanced Docker interview questions. We'll understand uses of Alpine Images. One of the most commonly asked Docker interview question is why are Alpine Images preferred? Now first let's understand what Alpine is. So Alpine Linux is a lightweight Linux distribution that is commonly used as a Docker base image. For example, from Alpine latest run APK, this is a code that I have written. Now, why do we organizations prefer Alpine? So there are four major reasons for that. First of all, the images are extremely small, around 5 MB. And because the images are smaller, they can be downloaded faster. And also smaller images reduce storage cost. And finally, because there are fewer packages installed, the attack surface is much smaller, which improves the overall security. So we can altogether say Alpine is preferred because it is significantly reduced image size, it improves deployment speed, it is saving storage and minimizing security vulnerabilities. What is image size optimization? Earlier we discussed about Alpine. This is quite similar. Why organizations care about the image size. Now large Docker images create several problems. They are responsible for slowing the CI/CD pipelines. So this leads to the increase in the deployment timings. More storage is getting consumed. So this is like cost. It is not much cost effective because they increase network transfer cost. Hence, we optimize the Docker images. And optimization can be done by using Alpine images, using multi-stage builds. If there are any unnecessary packages, then by removing that. And we also can do it by reducing the number of the layers. We can use the commands like dockerignore for that. And the question generally asked is how do you reduce Docker image size? So the solution is simple. We are using images which are consuming less size, which is like Alpine image. We are introducing multi-stage builds, minimizing the layers, removing unnecessary packages and files, unwanted files using Docker ignore. Now we understand like we will be using multi-stage builds, but what exactly is means by multi-stage builds? It's a very popular Docker interview question. A multi-stage build allows us to separate the build environment from the runtime environment. Now I'll explain it. Suppose we need a Node.js only during build time, but one application is built, we need Nginx to serve the static files. Now, instead of shipping everything into production, we copy only the required output. So the benefits are we get smaller images, we get better security, we get faster deployment. So multi-stage build uses multiple from statements to separate build and runtime environments. and this eventually reduces the final image size. Now, why Docker ignore is used? Let's talk about it. Docker ignore works similarly to git ignore. If you have come across git, it prevents unnecessary files from being copied into the Docker build content. So it's ignoring them. Common examples is .git, node modules, log files, readme files. So these files can be ignored by using Docker ignore and removing the unnecessary files. And the question can arise why we use Docker ignore. So Docker ignore prevents unnecessary files from being copied into Docker images, reducing the build time and also the image size. We'll understand the real world scenario. Let's move into production troubleshooting. Suppose there is a developer who says my application works perfectly on my laptop, but when it goes in the Docker it fails. How you would troubleshoot it? Whenever such issues occur, the first structured approach is by checking the logs. For checking the logs, we would use the command docker logs and the container ID. Next, enter the container. So for that, we will use docker exec dash it container idsh. It would give us an access to the container wherein we would view the environment variables, verify what are the mounted files, see what is going on in the networking. If there is any networking issue, inspect that. Compare if there are any dependencies between the local and the container environments, any dependencies issues that or any differences that we are getting. So how would be the troubleshooting steps in this scenario? Review the logs, validate environment variables because it is working on laptop but not in the Docker, verify mounted files, inspect the networking part, and compare the runtime dependencies. Second scenario based question they might ask, container exits after the setup immediately. Now, why does that happen? Most common reasons for a container to exist is the application is crashing, or there are wrong instructions, or there is a wrong entry point, or there are missing dependencies. So, important thing to remember is containers continue running only when we have the main process which is running. If the main processes are exiting, the containers will exit also. So the container stops immediately because the main process is exiting, or it is crashing, or it is not configured properly. We'll go to the scenario 3. Application is running inside a Docker, but the users are not able to access it. Certainly in this case, first we will have to verify whether the application is listening on the expected port. And for that, we would be using the command netstat -tulpn. Next, we will verify the expose ports by having the command run docker ps, showing the host to container port mapping. Example, docker run -p 8080 is 280 nginx. This is one of the example of the command. And how you would answer the interviewer? We are verifying the application binding address, exposed ports, port mapping, firewall rules, and container network settings. We'll go to the next scenario. After restarting a container, the data is getting disappeared. Why? Now, because data is stored inside a container's file system, containers are ephemeral. That means when containers are deleted, data inside them is also lost. So we had earlier discussed in the part 1 about the Docker volumes, and the solution is same. We would be using Docker volumes over here. We would create Docker volume create db data and Docker run dash v db data and then the address. So the interviewer answer for this would be very simple. Use Docker volumes or bind mounts to store data outside the container lifecycle. So if the data is disappearing after restarting the container, if the container is deleted and the data is lost, we can get it through the Docker volumes. We'll go to the next scenario based question. If a Docker image is 3 GB in size, how to optimize this? So the question is very simple. It's related to the image sizing. So they wanted to optimize it, means they want to everything investigate the image layers. So we can see Docker history, image name, look for large layers, see the possible improvements which can include. We can make use of the lighter images as discussed. We can make use of Alpine Images. We can go ahead and apply the multi-stage builds to minimize the size. We can go ahead and remove the caches and um, using the command dockerignore. Unnecessary dependencies we can remove. So overall we can analyze layers using Docker history, switch to Alpine image, implement multi-stage builds, and go ahead and remove all the unnecessary files and packages. Now, before we proceed ahead, I would like to give an information about history command. Now, Docker history is very important because it is widely used in troubleshooting part. So when we use Docker history image name, it will show the image layers along with their sizes. So in that case, we can easily do the root cause analysis over here to identify which layer is consuming excessive space. Now we will go ahead and see some production level Docker file. This is how that looks. Let's discuss it a bit. This now example I have shown is a combining several best practices. If you can see, it has used an Alpine image. There is a multi-stage build which is used over here. We have minimal runtime image, Nginx which is serving the static files. And why overall this looks good is because it's having a small image size, faster build times, security wise it is good, production readiness is available in this file. So the production Docker file should be lightweight, secure, maintainable and optimized for deployment speed. I have few additional advanced interview questions which I would go ahead and add to this series. So why should containers run as a non-root user? We had a tip like we should not run containers at the root user. Uh, why it is advised to run it as a non-root user. So running containers as a non-root users generally helps us to reduce the security risk because we are limiting privileges inside the containers. Next, what happens when Docker run is executed? After run, it will check for the image locally. If not available, it will pull it and create a writable container layer, configure the networking, and start the container process. How do communication happens with each other in the containers? So containers communicate through Docker networks, and it is done using container names or maybe their IP addresses. Difference between expose and -p. Expose is used to document the port inside the image, and the -p option publishes the port to the host machine. This is a very common interview question. How would you troubleshoot if there is a high CPU utilization usage in Docker? So the approach would be, first we will see the stats by using Docker stats, top and container ID to see the processes running, Docker inspect container ID to analyze utilization, running processes and configuration issues. Thank you and congratulations, because we have now covered some of the most important advanced Docker interview topics, which includes Alpine images, image optimization, multi-stage builds, and real-world troubleshooting. So if this video was helpful to you, please hit the like button and subscribe. We are building a complete DevOps interview series covering Docker, Kubernetes, Terraform, Linux, and Azure, Jenkins, and real world production scenarios. Comment below and tell me which topic you would like to see the next: Ansible, Azure, or advanced scenarios. Thank you for watching, and I will see you in the next DevOps interview series video.